works is if we have parallel lines. So we got parallel lines here. And basically that one that's splitting the side, hence the name side splitter of a triangle. Right? If those lines are parallel, we don't have to go through and show that the two triangles are similar or anything like that. We don't have to do side angle side, any of that stuff. We get to say that the proportion of the one side that was split is equal to the proportion of the other side split. And so we have A to E, and so the X to the Y, A to B, right? And then likewise, if they're proportional, then the lines are parallel, is what we can prove down the road, right? But the side splitters theorem is if we have a parallel line to one of the sides of our triangle is splitting the sides of the triangle, the proportion of the two sides being split up are equal, right? They're proportional. All right, so how's this going to work? Got to find your proportional lines, or your parallel lines. All right, so we got our parallel lines here. That means the side that was split is proportional to the other side split. And again, when we're writing our fractions, our ratios, we got to be consistent. So we did 8 over 10. They came from the same side. That means it's question mark, or we'll call that x over 15. And then we get to cross multiply and divide. 8 times 15 is 120. 10 times x is 10x. Divide both sides by 10. And x is equal to 12. So L to S, which was x, is equal to 12. All right, so side splitter theorem, if lines are parallel, we have lines parallel, that means this side's ratio of one side is proportional to the ratio of the other side. Well, you can do your cross multiplying and dividing if you'd like on this one, but since the top numbers of the fraction are the same and the bottom numbers of the fraction are the same, so they got to be b to k has got to be 4. All right, and this is the multiple side splitter theorem, essentially. If we have multiple parallel lines, multiple transversals, the proportion of any of the pieces, or the ratio, of any of the pieces is going to be proportional to the pieces of the other transversal. Right, so no matter where they go, no matter where they cut, what angle they're cutting in at, does not matter. The ratio of the pieces of one transversal are proportional. So x over y equals a over b. So the figure shows part of a freeway interchange. The raised freeway is supported by vertical going straight up and down. So we're talking about these guys, and they're parallel pillars. So here are my parallel lines. And so what we have is the ratio of this transversal sides or pieces to this transversal side pieces are proportional. So we would do 32 to the question mark, or x, which is then the same as 30 to 24. And then you get to cross multiply and divide. So you could do that on your own. That is the side splitter theorem. The other one we got is the triangle bisector theorem. So what we're looking for is the angle being split in half. You're looking for those markings, maybe same congruent angle measurements put in there. And the way this works is the angle bisector theorem, the triangle bisector theorem. The angle that's getting bisected by the bisector, that side, which is y to b, is proportional to the remaining two sides of the triangle. So the side split by the bisector is proportional to the other two sides. So it's important that we find out where that is. All right, so here's our angle bisector. Here is the bisecting ray or segment or line, whatever we want to call it. Okay, in this case it's a segment. So the bisector is intersecting this line, so we can take and write those two numbers, 2 and 4, as a ratio. And then since 4 and 2 were adjacent, then the 4 would go on top, and then the 4 and the question mark right here are adjacent. They're next to each other. They would go on top and bottom like that. And then we cross multiply and divide, and x is equal to 8. And c to e then is equal to 8. All right, again, find out the angle that's bisected. The bisector is here, splitting this side into two pieces. So we're going to write those two numbers as a fraction, 6 and question mark, or 6 and x. That means 6 and 9 are adjacent, and then question mark and 12 are adjacent. We set up our proportion, and we cross multiply and divide. X to z is 8. But if it said the distance from y to x, then we would do 8 and 6 and make 14. All right, so practice. There are a couple tough ones in the packet that we have. So if you have any questions, let me know, and we'll go over them in class. Have a good day.